Hi everyone, and welcome to the Superb AI Academy. My name is Sam, and today I'll be providing an overview of our new Curate module. Our Curate product is designed to streamline the data curation process, allowing teams to analyze their training datasets, search based on metadata using queries, and visualize dataset distributions using embeddings projected into two-dimensional space. I'll begin with the likely point of entry for most Curate users, starting with a large quantity of unlabeled data and using our auto-curate tool to select a subset for initial labeling. To kick off, you can import data to Curate a number of ways. For example, you could upload it using our simple SDK tools, or you can just pull it directly from our label module. For the purposes of this overview, let's pull some unlabeled data straight from a label project. It's as simple as filtering the data you want to use, which in this case is all the data in this project, and clicking Send to Curate. If the data is labeled, these will be moved over too, though in this example we'll be starting with unlabeled data. Once the data is moved over to Curate, the suite will start automatically generating embeddings for each image. This can take a little while, so we'll jump over to a dataset that already has embeddings created. These embeddings represent the visual properties of the image in a way that allows us to calculate similarities and differences between images, at both a high level and at the level of fine-grained details. With these embeddings generated, we can cluster images by visual similarity. We can get a rough idea of how this clustering works by taking a quick look at this example scatter view, which represents the embedding space in 2 dimensions. This is only an approximation, as our embeddings use 1024 dimensions, but it's a good way to get a sense of how our clustering works, and also to get some high-level insights into the distribution of your dataset. In this example, we can see how our clustering algorithm has grouped images of people playing baseball, beach images, and images of animals. This is how our auto-curate works on unlabeled data to pick the most effective and valuable subsets of your data for initial labeling and model training. With unlabeled data, the auto-curate algorithm can curate a dataset of unlabeled images with an even distribution and minimum redundancy, as opposed to a random sampling, which will likely overselect from large groups of visually similar images. Kicking this off is as simple as clicking Auto-Curate, selecting Curate What to Label, choosing the number of images you want curated, and picking a name for your curated slice. Auto-Curate will take some minutes to complete, so let's take a look at a report from an auto-curation I ran earlier. This report will compare the curated subset with a random sampling of the same size. We can see that our algorithm identifies a total of a bit under 7,000 clusters. Our curated subset has examples from all of these clusters, whereas the random sampling has examples from just over half. We can see this difference even more dramatically when we look at the clustering sampling with respect to the sizes of the clusters. Small clusters here are either single images or small groups of images that are distinct from other images in the dataset, and as such are likely to contain rarer edge case objects. As we can see, the random sampling fails to sample a significant majority of clusters that are between 1 and 5 images in size, whereas the auto-curated subset contains examples from every cluster. Looking a little further into the report, we can see some examples of sparser and denser clusters that were identified. Looking at these dense clusters, it's quite likely that there are visually similar clusters of low light or nighttime images that may contain a lot of redundancy, and it's possible that a random sample could overrepresent these redundant, low-value images. And with this auto-curate complete, we can just navigate to this slice and send it directly to a project in our label module for labeling, QAing, and exporting. Now, auto-curate isn't just for this initial selection of unlabeled data. It can also be used to work with labeled data in a number of ways, and as mentioned previously, you can also import labeled data directly from the label module. When working with labeled data, the Curate module generates embeddings not just at the image level, but at the object level. As you can see, on this auto-curate menu, we have 3 additional options, all for working with labeled data. I'm going to cover these each briefly. First, we have the option to curate a training and validation set split for model training. This allows us to split our labeled data into training and validation subsets, making sure that at a high level, there's an even balance of class presence across the split, but also making sure that at the embedding level, there's an even balance of object clusters. This will also highlight possible mislabels in the dataset by looking for individual objects that are distinctly clustered with objects of a different class. These may need to be reviewed further, or removed from the dataset before model training. Next, we have the edge case detection option. This lets you drill down and specifically identify edge cases at the object level by finding objects within a class that are semantically distinct from the rest of the class using our clustering algorithms. And finally, we have the standalone mislabel detection, which performs the same function as the mislabel detection in the training and validation split. I briefly looked at using slices to manage data as part of AutoCurate, but slicing, along with our querying tool, are critical features in their own right. We can use the query builder to filter subsets of our data by raw image features, such as dimensions or file size, image metadata, which can be uploaded along with the images or added later, or, once the images have been labeled, annotations, or any combination of the above. Once we've filtered these subsets, we can save them as slices or add them to existing slices for use in further labeling, quality control, or model training. Keep an eye out for the videos that we'll be releasing soon that cover the features I've touched on in more depth. I'll see you next time.